A chemical equilibrium. So what exactly is a chemical equilibrium? Now let's say we have a reaction that says A plus B makes C. That reaction has to be reversible, meaning that the reactants can make products and the products are also able to make reactants. Now, let's say we have a graph, right, and this is time and this is rate. At the beginning, the rate of reactants making products will be extremely high. And then over time, it will slow down and become constant. And likewise, the rate of products making reactants will be 0. And over time, it will speed up and then become constant. And once the rates are equal, then you can say that the reaction is at equilibrium. It means that the rate of the forward reaction equals the rate of the reverse. Alright, now let's talk about the letter K. Now K is the equilibrium constant, and it equals the concentration of the products over the concentration of the reactants raised to their coefficient. So if I had a 2 here and a 3 here, K would be equal the concentration of C cubed divided by A squared times B to the 1. Now, there's also a reverse reaction. So the K for the reverse reaction would equal 1 over K inverse, where B and A are the products. So concentration of A squared times B over concentration of C cubed. Some things to consider about K. Remember that only aqueous and gases count towards the equilibrium. And that means that pure solids and liquids do not count and are not considered in the equation. So if I had another product, let's say D, and that was a solid, then you would not include it in either of the equations. Also keep in mind that K can only be changed by temperature, by increasing or decreasing the temperature. So if you add products or reactants, or if you add a catalyst or anything else, it will not change K. So it's only changed by temperature. Over Le Chatelier's principle real quick. This is pretty straightforward and pretty simple concept to know. Basically, it states that whenever there is a stress on a chemical reaction, the reaction will shift either towards the products or towards the reactants, depending on what the stress is, to relieve that stress. So let's say you have an equation here, A plus B makes C plus heat, and it's an exothermic reaction, so delta H is negative. Let's say if you increase the temperature, right, since heat is a product, the reaction will shift towards the reactant side, will shift to the left to relieve the stress. And let's say if you add too much reactants, let's say if you increase A, the reaction will shift towards the right, shift towards the product side to get rid of that, get rid of the extra A to restore the equilibrium. And it's pretty simple. Now, what if they're gases? Let's say it's a gas, right? Yeah. Now, let's say it's a gas, right? All the reactants and the products are gases, and we're in a non-rigid. Oh, hold on. Okay, we are in a non-rigid container, meaning that the volume can change. So if you increase the volume, you are decreasing the pressure. So what the reaction will do is that it will shift towards the side with more moles of gas, right? So in this case, it will be towards the reactants. It will shift towards the side with more gas to increase the pressure and relieve the stress. Now, conversely, if you decrease the volume, you are increasing the pressure and the reaction will shift towards the side with less amount of gas so that the pressure will go back down. Yeah, pretty simple. And now what if you add a gas that, let's say you add gas D, right? Now, like an inert gas, for example, in a non-rigid container, it, so it means that the volume can change, right? In a non-rigid container, if you add more gas, the volume will go up, which means that the pressure will go down. And since the pressure is going down, the reaction will shift towards the side with more gas, so that the pressure will go back up again. And it's the same thing. Well, you don't really need to know that. Now, since gas D is not in the equation, right, it really won't. Okay, now what if it's a rigid container? Means that the volume does not change. So if you add an inert gas, or a gas that's not in the equation, it will have no effect on the equilibrium position, right? Because the volume doesn't change and the pressure does not really change at all. However, the total pressure does change, but you still have no effect on the overall equilibrium position. And yeah, it's pretty simple as that. Alright, so here we have a problem given an equation, and it asks us to write the equilibrium expression. So remember that the equilibrium expression is products over reactants raised to their coefficient. So here we have calcium hydroxide, which is a solid. So we're going to write a 0 for that, because remember, solids and liquids do not count in our equilibrium expression. Only gaseous and aqueous solutions. So now we have C2H2, which is a gas, and it has a 1 next to it. So we're going to write a 1 here. Next we have calcium carbide, which is a solid, so we're going to write 0. And water, which is a pure liquid, which also does not count towards our equilibrium expression, so we're going to write a 0. And if you submit the answer, we would see that that's correct. So let's do another one. Okay, my people, so here we have another practice problem, and it's a true or false question given the scenario. So the first one is, for a reaction with K is less than 1, the rate of the forward reaction is less than the rate of the reverse at equilibrium. So we know that's false because it says it's at equilibrium, which means the rate of forward equals the rate of the reverse. So that's false. The second one says the value of K at constant temperature does not depend on the amount of reactants and products that are mixed together initially. So that's true because we know that K depends on temperature and can only be changed by temperature. The third one says a small value of K means the equilibrium position lies far to the right, that a lot of products will be present at equilibrium. So that's also false because we know that K is a ratio of products over reactants raised to their coefficient. And a small value means that there are a lot of reactants present, not products, so that's false. And lastly, if K equals 8 for this reaction, K will also equal 8 for the reverse reaction. So we also know that that's also false because for the reverse reaction, it has to be 1 over K. It would be the inverse. So yeah, that's false. And if we submit our answer, we would see that it's all correct.